Hey guys, we're going to tackle a really big bear today, and it's called Solving Rational Equations. Today, this is going to be a 2-day lesson for us. Today, we're going to focus on what we call part one. And basically, a lot of the resulting equations that we get into will be factorable, and we'll get some really nice rational answers. And then in part two of this topic, we'll get some irrational answers as a result of the quadratic formula and things like that. So without further ado, let's see what we got in store for us today. So what we're going to be doing, we've been spending a lot of time with rational expressions. Can we simplify them? Can we multiply them, divide, add, subtract, all of those things? So today we're actually going to see some equations. Believe it or not, you probably didn't even realize this, but we actually haven't seen an equation in a long time. You'll notice, so we're going to see equal signs here, and we're literally just solving for x. In other words, what value of x would satisfy this equation? So these are some of the bears that we're going to get into today. And it's kind of like riding a bike. We might fall down a few times, but I tell you what, once we get it, we're really going to take off. So here's our rough game plan. And what I'm going to do is I'm kind of copy and paste this game plan into next to each problem, so we can kind of go through and check off the steps as we go through. Because sometimes these steps look like they're written in Chinese until you see them come to life as we're solving a real example here. Okay, so the first example here is a very nice warm-up one, very easy one. But our whole goal is I want to get rid of these fractions. I'm not comfortable with these fractions, and I want to do whatever I can to cancel them out or clear them out. So what I want to do is I want to consider these denominators right here. And I want to try to come up with the least common denominator. In this case, we could already check off step number one because there really wasn't anything that was factorable in this one. That won't really become an issue until we start to see some binomials and trinomials later on in the problem or in the video. So to come up with the least common denominator, one trick you can use in this one is just to write out the multiples of each of these numbers. So for 8, we've got 8, 16, 24, 32, 40, etc., etc. The multiples of 5 are going to be 5, 10, 15, 20, 25, 30, 35, 40. Boom, boom, boom. And then the multiples of 10 would be 10, 20, 30, 40, and boom, boom, boom. So what you'll notice is that 40 showed up on all three of the lists. That was the smallest number that showed up on every list. So I'm going to consider that my least common denominator, and I'm going to kind of distribute that throughout the entire equation, okay? So imagine yourself putting brackets around the equation, and we're going to distribute a 40 to all three terms in this case. So what that's going to start to look like, so let's say, so I'm going to go, I've got 40 over 1 times 5 over 8 minus 40 over 1 times 3 over 5 equals 40 over 1 times x over 10. So one really cool thing is I like to reduce these guys as I go through. So for instance, 8 goes into 40 5 times, right? And then I'll multiply this 5 and this 5 to get 25. Then we could say, well, 5 goes into 40 8 times, and this 8 times 3 makes 24. And 10 goes into 40 4 times, and 4 times x makes 4x. Isn't that slick, huh? So we were able to clear the fractions, so to speak, right? So we can check that off of our list. We've distributed, we've cleared our fractions. And step 4 says, just focus on solving the resulting equation, right? So we could, let's see, well, 25 minus 24 makes 1. And we could divide the 4 over, and we got 1/4 equals x. So the only other thing left to do is to check your answer with the original equation, right? So let me just take a peek, make sure I got the right original. So here's my check over here, and we're going to use our calculator a lot for this. So you got 5/8 minus 3/5 equals 1/4 divided by 10. So we're just substituting that 1/4 for x. And what we could do is we could plug this into our calculator. We'll plug this into our calculator, and I think we're going to get 0.025 and also 0.025 over here. So we check, and our final solution is indeed the 1/4. So we do want to be very diligent with those checks, because I think we will run into some extraneous solutions like we've seen in some earlier topics that we worked on earlier this year. Okay, so again, step number 1 doesn't apply because there's nothing to actually factor. Now, as far as the least common denominator goes, if you want to put any term that doesn't look like a fraction, you can just put it over 1. And so when you consider your 3 denominators, the LCD is just going to be x itself. So my game plan says I want to distribute that to all terms. We could put x over 1 and distribute it, and it would start to look like this. 12 over x. Again, remember, the reason we're doing this is we're trying to clear the fractions and get all of those denominators. Whoopsie, that shouldn't be an x. We're trying to get them all to cancel out, right? So for right here, nothing is cancelable, so we'll just multiply the x and the x to get x squared. But then on the second term, we could cancel the x's, and you just get minus 12. And then over here, nothing cancels, so you'll just get x. We're in a really good place right now. We're in a really good place. So we've distributed, we've cleared our fractions. So now all we got to do is worry about step 4, solving the resulting equation. And this is just really good review from something we've, worked with earlier in the year. We're going to try to subtract that x over so that everything's set equal to 0. We know it's going to factor into x minus 4, x plus 3. And we'll get x equals 4 as a solution. We'll get x equals negative 3 as a solution. And then we just got to work our way through our checks where we substitute the 4 for x, confirm it, substitute the negative 3 for x, confirm it, and we're off to the races. Okay, so this one's a little more challenging because we've got a monomial and a binomial. Now, you do want to check to see if anything's factorable, but I don't think anything can be factored, so we'll cross that off the list again. So what is our LCD? Okay, our LCD is going to be the product of x and x plus 2. Okay, so we're going to go ahead and distribute that. Say x times x plus 2 all over 1. We're going to go ahead and distribute that to all 3 terms. So this is a much, much more challenging example than what we've seen in the previous ones. Okay, so I'm just going to take my time and distribute that LCD to the first term. Then we'll distribute it to the second term, which is 8 over x plus 2. And we'll distribute it to the third term, which is just, times, we'll say 4 over 1. We'll put that little rascal over 1. Now, again, the reason for distributing that LCD is so that we could clear the fractions, right? So what's happening here is this x cancels with this x, and then you just distribute your 4 to get 4x plus 8. How sweet is that, huh? All right, now we're going to cancel the x plus 2 with the x plus 2, and then we'll multiply the x and the 8 to get minus 8x. And then over here, unfortunately, when you look at this term, nothing cancels. So we're going to distribute the x, and then we're going to distribute the 4. And that's going to give you 4x squared plus 8x. All right, so now we're up to step number 4. And we just want to solve the resulting equation, right? Just solve the resulting equation. We're going to try to get all the terms on one side and then hope and pray that it factors, right? Looks like in this case, I'm going to move everything to the right. Let's see here. 16 minus 4. I think I'm going to get 12x when we combine all those terms, and then we'll get minus 8. Now, thank goodness, I thought when I first saw the 4, I was thinking, oh no, I got to do guess and check. But luckily, I do see a GCF. So I could factor out that 4, and then we'll say, okay, we got the quantity x minus, oh boy, maybe that's not factorable. Oh, shucks, you know what? That's not factorable, so I must have made a mistake. Let me take a peek at my notes here real quick. Aha, okay. This is going to be a really easy fix. I screwed up in the original here. This this minus sign was supposed to be a plus sign. Okay, so this is going to be a really easy fix. Change that to a plus. So we got a plus sign right here. We got a plus sign right here. Okay, so what that's going to do is the 4x and the 8x make 12x, and then I'm going to subtract that over from this guy. So that's going to make, let's see here, negative 4x right here in the middle. And I think that everything else is intact. Okay, so now I just got to, let's see, we'll erase this guy. So that's going to be just minus x once I take out the GCF of 4. And then, yeah, how about that? It is going to factor now into x minus 2, x plus 1. Whew, thank goodness. Now, when you go to tee this up, the 4 is irrelevant, okay, because certainly 4 can't equal 0. But what you could get is you could get x equals 2 as a solution. X could be negative 1, and those are your two solutions. Now, one thing you want to make sure is, let's write this in our notebooks, make sure the denominators do not equal 0. Okay, and what I mean by that is if you go back up to the original. Okay, so for instance, we were talking about like the domain of these rational functions in an earlier video. What you want to do is you want to make sure, okay, we'll say this x cannot equal 0, and this x right here cannot equal negative 2. X cannot equal 0. X cannot equal negative 2. So what happens is if you would have gotten 0 or negative 2 as a solution, we would have automatically had to reject it. But in this case, we just got positive 2 and negative 1. So both of those are going to check out real nice. Okay, both of those are going to check out real nice. Let's go ahead and get one more big bear in here, and we'll finish with this rascal. This is the first time where we really get a chance to practice step number 1, where we got to factor all the polynomial expressions, because we got to factor this x squared minus x minus 12. And I believe that's going to go to x minus 4, x plus 3. Okay. Whoopsie daisy. Let's make that a plus sign. All right. No more mistakes, Hill. All right. 5 over x plus 3 equals 2 over x minus 4. And you're just thinking, like, what's it going to take to cancel out these denominators, right? What's it going to take? I'm going to say my LCD is the product of x minus 4 and x plus 3. And that's what I'm going to go ahead and I'm going to try to distribute to all the terms here. So x minus 4 and x plus 3. And I'm going to go ahead and distribute. And so we definitely have our hands full with a big old bear here. So it's going to take me just a second to rewrite these all out. So we're distributing to the first term, and I can see that a lot of good things are going to cancel right there. And then, let's see, we're going to distribute to the second term. Might have to be careful with my handwriting here, or I'm going to run out of room. And then we'll distribute to the third term. We're going to squeeze it in. 2 over x minus 4. That was a close call. Okay, so first things first. All right, in this first term here, we're going to cancel the x minus 4s. We're going to cancel the x plus 3. And the only thing we're left with is 2x. On our second term right here, we can cancel the x plus 3s. Then we'll take this 5 and distribute it into the x minus 4 to get 5x minus 20 equals, okay, on the third term, we'll cancel the x minus 4s and then distribute the 2. How much fun is this? This is good stuff, isn't it? This is good stuff. All right, now just solve the resulting equation, right? So I'm going to maybe just take a nice baby step here. I'm going to combine the like terms here. We'll go 7x minus 20 equals 2x plus 6. Now, what's interesting here is this is actually just a linear function compared to the previous few examples. They were quadratics. So instead of setting the equation equal to 0, I just want to get my x's on the left side and my constants on the right-hand side. So I'm going to subtract a 2x from both sides, and then I'm going to add a 20 to both sides. and we'll get x equals 26 over 5. And I'll tell you what, anytime I get an interesting number like that, I get a little bit nervous as to whether it's the correct answer or not. So I certainly want to try to check that answer. One thing that I would do is on my calculator, I would type in 26 over 26 over 5, and I would store that as x, or alpha a or something like that. And then I would just retype the equation on my calculator. Remember, our game plan says we want to check it with the original, right? So go back to the very beginning, and we're going to check this on our calculator. And how about that? When I typed in the left side, I got 5/3, or maybe your calculator said 1.6 repeating. And on the other side, I got 5/3 as well. Hot diggity, it does check. So our solution is 26 over 5, and we're good to go. So we're going to practice a couple more in class tomorrow, and then we're going to turn you loose and let you showcase your skills on that homework. But again, just some good quality practice. I think you're going to be dynamite.